It is the second part of section 8.2. Here we'll study integration by parts for definite integrals and for special functions, particularly for inverses of functions. For definite integral, we can use the second part of fundamental theorem of calculus. And for definite integral, we can find the antiderivative and then evaluate the lower bound and upper bound and try to get the difference. That's the second part of the fundamental theorem of calculus. And integration by parts formulas can be combined with that. Okay, here, let's try to solve this problem. Find the area of the region bounded by the curve y equal x times e to the minus x and x-axis from x0 to x4. So the problem is asking to evaluate the integral from 0 to 4. Now the function x e to the minus x dx. Okay. Now let's try to use integration by parts. That is now u, and that will be v prime. Then v must be minus e to the minus x. Okay. So here, from this one, the given integral is the same as now uv, which is minus here x e to the minus x, and here minus, and u prime, which is 1, and here v is minus e to the minus x and dx. Of course, after getting the antiderivative, we have to evaluate the function from 0 to 4. Right? Okay, now try to get antiderivative for that one. So that there is a minus x and e to the minus x, and that is same as minus e to the minus x. So that is same as minus x plus 1 and e to the minus x. Now we have to evaluate from 0 to 4. Okay? Then that's it. You can finish the computation yourself. Okay, now we'll try to apply integration by parts for the inverses of functions. Now, the integrand is inverse of some function. Then, now we may start with y equal f inverse of x. Then, that is the same as x equal f of y. That is the definition of inverse. Now, so that dx is same as now f prime y dy. So here, the f inverse of x is the same as y, and dx is the same as now f prime y dy. Right? Then, by using the integration by parts, here we may consider this portion as u, and there's a v prime. Okay, then now here u v is same as this one minus and integral, and u prime is now 1 and v is f of y dy. Now y is the same as f inverse of x. That portion is changed into this one, and then f of y is the same as x here. X is f of y. So it's a change into a function of x. And now here, the same term. So we here summarize f inverse of x dx is same as x f inverse of x minus f of y and dy. Of course, after getting the integral, after evaluating this integral, this is a function of y, and y must be replaced with f inverse of x. Right? Okay. let's try to solve this problem. Now here, y call f inverse of x can be considered as a substitution. Here for this one, we'll try to solve along with that derivation, and for that one, we'll try to use this formula. Okay, now here, that is cosine inverse x, so that we choose y substitution, y call cosine inverse of x. That means that there is x is now cosine of y, so that here dy, okay, dx is same as minus now sine y and dy, right? Okay, so the given integral is changed into here cosine inverse of x is y, so that that is now y. Now dx is minus sine y and dy. So here for this one, we may consider that is now u, and this is now v prime. Then v must be cosine of y. So that is the same as uv y and cosine of y, and minus here integral, and u prime is 1, v is now cosine of y dy. Now if you solve this problem, then y cosine y and minus, okay, antiderivative of cosine y is sine y and plus c. Now we have to replace y with that definition. So here y is cosine inverse of x, cosine y is x, so that one is x, so x, now y is cosine inverse of x, and minus here sine y itself is cosine inverse of x, okay, and then plus c. That's the final answer. So sometimes if you have inverse is given, then so that there's a f inverse of x, then you start with a change variable y and here try to figure it out in this way. Even though you may not memorize this formula, then basically this is a change of variable technique, so substitution technique, so that you can solve the problem, right? Okay. Now for that one, just now we try to use the formula. Okay. Here, that is, okay, we consider this one as here f inverse of x. Okay, that is f inverse of x is now here log 2 over x. Okay, if we write that this is y, then x will be same as here, okay, 2 to the y, which is f of y, right? Okay, now try to use the formula. Okay, x, f inverse of x. Now x itself, so the log base 2 of x, and minus, what is fy? There's 2 to the y, so that 2 to the y and dy. Of course, after getting antiderivative, we have to evaluate the whole function from 1 to e, right? Okay. Now here, for this one, x, logarithm 2x, and minus, that is the same as 2 to the y over logarithm 2. Now, what is 2 to the y? 2 to the y is x, so that we can write down this one here. There's x, and then so that, and there's x log base 2 of x, and there's minus x over now logarithm 2. And we evaluate from 1 to e, right? Okay, here for the first term, once is okay. Now we'll see in this way. That one, okay, we can rewrite this one in this way. Now log of 2x is by using the base change, we can write down this one in this way: x logarithm x over logarithm 2 and minus x over logarithm 2, and here from 1 to e. Okay, now once it's e, then 1, so that e over logarithm 2, there's 1, then it's 0. Okay, for the second term, there's e minus 1 divided by logarithm 2, so that the final answer must be 1 over logarithm 2. Okay, that's the final answer. Now we have here recursive formula, and for example, and if we want to get the integral for cosine to the n of x, then here we separate here. Now u is cosine to the n minus 1, and v prime is cosine x. Then now derivative of u is now the power is n minus 2 and the sine x, and antiderivative of cosine x is a sine x. So thereby using the integration by parts, here that is here uv minus, and along with this minus it becomes positive, and here this term and sine x is here v prime, u prime, and v is a sine x. Now for this one here, now sine squared x, for that term we can use 1 minus cosine squared, and then algebraically we rearrange it. That one is the same, and along with 1 here, now power n minus 2, cosine power n minus 2 dx, and the second portion is here now with this negation and n minus 1 and cosine to the nx dx. So we have here that term and here another term. So we'll move this one to the other side. Then 1 plus n minus 1 is n. So we reach at n times of the required term, the required integral is the same as the remainder part here. So divided by n, we can reach this formula. So it is a recursive formula, and power n then is along with this term and constant times power n minus 2. And so that, for example, as n is 3, then we can reach at this one, that term, and 2 over 3 and cosine x dx. Now, this can be done quite easily. Now, integral is sine x, so we can reach at that one. Now, similarly, for power of sine x, you can make a formula. However, you should not try to memorize this formula. And later on, and we'll deal with details of trigonometric integrals, and particularly in the next section here, power of sine and power of cosine will be treated, and also in power of tangent and power the sec function, and will be also treated in the next section. Anyway, we'll try to deal with these integrals from a little bit different angle, so that don't try to memorize these recursive formulas. Okay, that is the end of the section. Thank you.